In this video, we will explore different pick-and-place applications and show the main considerations needed to successfully deploy them using the latest on-robot tools. On this pick-and-place application, the robot picks the workpiece from a fixed position in the in-feed conveyor and places it on a part bin on a pre-arranged pattern. Once the part bin is full, the out-feed conveyor will move it to its next process. The workpiece handled on this application is a machined brake caliper. Given its dimensions, shape and weight, the RG2 is the ideal gripper to pick and handle this workpiece. The in-feed strategy deployed on this cell is a conveyor system. The workpiece travels along the conveyor, and once the part presence sensor is triggered by the passing workpiece, it signals the robot that the part is present and ready to be picked up. The outfeed strategy implemented on this pick-and-place cell consists of a conveyor which transports a parts bin to where the workpiece is placed. A part presence sensor is used to stop the conveyor once the parts bin passes by and triggers it. The parts bin can fit 6 pieces of the workpiece arranged 2 by 3 in a single layer pattern. Once all the workpieces are placed, the conveyor releases the parts bin and it moves to the end to be collected and stored. On this pick-and-place application, the process starts when small, boxed parts come via the in-feed conveyor. It stops on the end of the conveyor and the robot picks up 2 full boxes at the same time. The robot then places these boxed parts to a shipping box where, once it's full, it will move on to the next station where it will be sealed and palletized afterwards. The workpiece on this application are laminated boxes, which the VG10 can handle. 2 boxes are picked simultaneously by the robot using the 2 independent vacuum channels of the VG10. The in-feed utilizes a conveyor system which brings the boxes to the picking position. With the help of part presence sensors, the boxes are picked in the right quantity all the time. The outfeed on this pick-and-place application is a conveyor. The picked workpieces are placed in the larger shipping boxes, which has a capacity of 6. A part presence sensor always monitors that the shipping box is in place, and once full, it will be moved via the conveyor to the next station for processing. On this pick-and-place application, the robot picks a glass filter and places it on a quality inspection machine for processing. This machine checks the glass for any imperfections and ensures that the glass is of the highest quality. Once this process is done, the glass is taken out of the machine and placed on a parts tray. The workpiece being handled is made out of glass, thus it is very fragile and must be handled with great precision. The RG2 FT is perfect for this task, as it has built-in force torque and proximity sensors and can handle the glass with the utmost of care. The in-feed strategy used on this cell is a tray system, wherein the glass pieces are arranged in a uniform pattern. The robot gently picks the glass piece from the parts tray, and once this whole tray is empty, it is easily replaced with a new set. The outfeed on this cell is similar to that of the in-feed, wherein the glass is gently placed on a tray after the inspection process. Once it is full, it is replaced manually by the operator. On this pick-and-place application, freshly baked bread on a tray travels along a conveyor ready to be packaged. Handling of food items like baked goods on this application requires the material that is in direct contact with food to be food-grade certified. Food grade means that the material is either safe for human consumption or it is okay to come into direct contact with food products. The on-robot soft gripper complies with this regulation and is certified under the Europe and USA FDA regulations. As the item being handled is a bread, the soft gripper has food-grade silicon molded fingers to gently pick the bread and place it on the packaging. The 4-finger variant is perfect as it can pick up long and unusually shaped pieces similar to the bread on this process. The tray of bread travels along an in-feed conveyor and stops on the designated picking area. Once the parts sensor is triggered, the robot proceeds to pick the bread. The bread is gently placed on its packaging container. One container contains 2 breads. Once the packaging container is of the correct quantity, it is released by the conveyor for its next process. The outfeed is monitored by a parts present sensor to make sure the container is there when the robot places the bread. On this pick-and-place application, a robot picks up a machined workpiece from a tray and places it on a laser marking machine for engraving. Once the laser marking process is done, the robot picks the workpiece from the machine and places it back to the parts tray. The cycle continues until all the parts tray have been processed. The machined workpiece has flat surfaces on the side and can be easily handled by the 2 FG7. With its small footprint and flat finger profile, it can easily grasp the workpiece precisely. The high gripping force of the 2 FG7 ensures the workpiece is moved securely and is picked and placed within the defined tolerance. The workpiece is presented to the robot in a parts tray neatly arranged in a grid pattern. The robot is programmed to pick all the workpiece and place it on the laser machine. For the outfeed, once the laser marking process is done, the finished workpiece is deposited back to the same parts tray. Once all the parts tray are processed, the machine will signal the operator to remove and replenish with a new batch. In this last pick-and-place application, the robot picks up camera lens filters from a conveyor belt and sorts them based on their manufacturing quality. The on-robot eyes vision system is used to locate and inspect the lens filters for imperfections. The camera lens filters are made of thin glass and must be carefully picked up. Their smooth and clean surface easily adheres to the gecko pad. After releasing the lens filters, the gripper leaves no residue or marks on the shiny glass surface, making it perfect for this application. The lens filters are transported on a conveyor belt. Once they reach the picking location, the vision system detects and inspects the lens filters for any imperfection. They are then picked up by the robot based on the position information also provided by the vision system. The robot transports and places the lens filters in different trays based on their inspection result. Parts that pass the quality inspection are placed on a tray for further processing. Defective parts are separated for analysis and to identify the underlying problems behind their defects.